Let's start with the 18th question. Point A comma B is the midpoint of a line segment between the axes, right? So this is your line between axes. Then this point A comma B is the midpoint of line segment AB. So I will take this point as P comma 0 and this as Q comma 0. Now how this becomes P and Q, as I will assume let the equation of line in intercept form B x by P plus y by q is equal to 1. As you can see that my x intercept is p and y intercept is q. That's why the coordinate of a and b will be p comma 0 and 0 comma q. Right. So this is our equation. Now, as my x intercept is p and y intercept is q, the coordinates of A and B will be P comma 0 and 0 comma Q respectively. Right. P A comma B is the midpoint of line segment AB. So P A comma B can be written as x1 plus x2 by 2, y1 plus y2 by 2. This is your midpoint here. B plus 0 by 2 and 0 plus q by 2. So on comparing, I will have A is equal to P by 2 and B is equal to Q by 2. So I will have P is equal to 2A and Q is equal to 2B. So keeping in equation 1 x by p, I will keep is as 2a and y by q, I will keep this as 2b is equal to 1. So I will get x by a plus y by b is equal to 2, which is the required proof. Let's try to understand the 19th question. Point R h comma k divides a line segment between the axes in ratio 1 is to 2. Find the equation of line. So I will assume let the equation of line in intercept form be x by a plus y by b is equal to 1. Therefore, my x intercept is A and y-intercept is B. So if I draw this on graph, then this is my point A, which is A comma 0, and this is my point B, which is 0 comma B. Therefore, the coordinates of the points on axis will be A, A comma 0 and comma B. Point RH comma K divides line segment AB in ratio 1 is to 2 from A's side. So if I draw this, then this is my point A, which is A comma 0. This is my point B, which is 0 comma B. This is my point R H comma K, which is dividing in ratio 1 is to 2. So according to section formula, point R comma H R H comma K can be found out using formula mx2 plus mx1 upon m plus n, my2 plus my1 upon m plus n. This is your section formula. So this is m is to n. So 1 into x2 is 0 plus 2 into a upon 1 plus 2 my2 plus my1 upon m plus n. So h comma k is equal to a by 3 comma b by 3. So on comparing, I will have h is equal to 2a by 3 and k is equal to 2b by 3. So if I subtract a and b, then I will have a is equal to 3h by 2 and b will be 3k. So keeping the value of a and b in equation 1, this is my equation 1. So keeping in equation 1, I will have x upon 3h by 2 plus y upon 3k is equal to 1. So this will be 2x upon 3h plus y by 3k is equal to 1. So if I simplify this, I will have 2kx plus hy is equal to 3hk. Multiplying this equation by 3hk, the final equation will be, I am writing this down again, and it will be 2kx plus hy is equal to 3hk. Right, I am multiplying this equation by 3hk. I will get 2kx plus hy is equal to 3h. So let's try to understand 20th question by using the concept of equation of line. Prove that the 3.3 comma 0 minus 2 comma minus 2 and 8 comma 2 are collinear. Therefore, we will write the given points are A 3 comma 0, B minus 2 comma minus 2, and C 8 comma 2. Right. Therefore, the equation of line passing through AB here I will apply 2 point form y y minus y1 upon y2 minus y1 is equal to x minus x1 upon x2 minus x1. And the points I will consider will be A and B. So my y1 will be 0, y2 will be minus 2 minus 0, x minus x1 will be 3 upon x2 minus x. Therefore y upon minus 2 is equal to x minus 3 upon minus 5. So 5y is equal to 2x minus 6, or 2x minus 5y is equal to 6. This is the equation of line AB. If this line satisfies the point C, then I can say that these 3 points are on the same line. Therefore, they are common. So now, keeping point 8 comma 2 in equation 1. This is my equation 1. So 2 into, in place of x I will keep 8, minus 5 into, in place of y I will keep 2, is equal to 6. Therefore 16 minus 10 is equal to 6. You can see that 6 is equal to 6. Left hand side is equal to right hand side. Therefore point C lies on line given in equation, that is point C is on line AB. Therefore A, B, C are collinear points. I can say that. We'll try to understand two formulas, that is finding the perpendicular distance of a point outside the line. Perpendicular distance of a point outside the line. So if I assume the point P, x comma y, x1, y1, it is outside the line, which is ax plus by plus equal to 0. So if you are interested in finding this perpendicular distance z, then this perpendicular distance z can be found out using the formula a. In place of x, you will keep the x coordinate of point P plus y in B into. In place of y, you will keep the y coordinate of point P plus c upon square root of a square plus b square. Whereas the perpendicular distance between two parallel lines, see, if one line is ax plus by plus c1 equal to 0, or equal to c1, and another line is ax plus by is equal to c2, you know that if the two lines are parallel lines, then the coefficient of x and y will be same. Therefore, the perpendicular distance P in this case, see, this is two parallel lines, and if you are interested in finding the perpendicular distance between these two lines, then this is mod c1 minus c2 upon square root a square plus b square. So these are the formulas of finding the perpendicular distance. Huh? Be careful, perpendicular distance. So this is the perpendicular distance of a point outside the line, which is mod a x1 plus by1 plus c upon square root a square plus b square. Whereas this is the perpendicular distance between uh, two parallel lines. The condition over here is the coefficient of x and y should be same. If it is not, then you have to make it same. Parallel lines will have their coefficient either same or in the form of multiple of uh, multiples, right? So if they are in the form of multiples, then you should make their coefficient same, and then you should apply this formula, c1 minus c2 upon square root a square plus b square. Exercise 10.3, first question. Here we have to reduce the equation in slope intercept form. You know that slope intercept form is y is equal to mx plus c. So here the first equation given is x plus 7y equal to 0. So we will subject y. So I can write this as 7y is equal to minus x, therefore y is equal to minus 1 by 7x plus 0. So on comparing with y is equal to mx plus c, my slope is minus 1 by 7, whereas y intercept, which is c, is 0. Right? Likewise, if I move on to the second question, then it is 6x plus 3y minus 5 is equal to 0. This is the given equation. So 3y is equal to 5, that is minus 6x plus 5. And if I divide this with 3, then minus 2x plus 5 by 3. So on comparing with y is equal to mx plus c, I will have m, that is slope, is equal to minus 2, and y intercept as 5 by 3. If I move on to the third question, then the equation given is y is equal to 0. So I can write this as m into, that is 0 into x plus 0. So on comparing with y is equal to mx plus c, my slope is also 0 and y intercept is also 0. Let's try to understand. Second question, here we are asked to convert or reduce the equation in intercept form. You know that the intercept form is x by a plus y by b is equal to 1. So here the given equation is this. So I will try to make my constant term as 1. So here I will divide this whole equation by 12. So I will have, so on comparing with x by a plus y by b is equal to 1, my x intercept is 4, whereas y intercept is 6. If I move on to second question, then the equation given is 4x minus 3y is equal to 6. So I will divide this equation by 6. So x will be 6 by 4 plus y upon minus 6 by 3 is equal to 1. So x by 3 by 2 plus y upon minus 2 equation. So on comparing with by a plus y by b is equal to 1. My x-intercept is 3 by 2, whereas y-intercept is minus 2. Right. The third equation given is somewhat different. As you can see that you don't have any term of x. So here there will be no x intercept, and if I subject my y, then my y will be minus 2 by 3. So here only y intercept is only there, which is minus 2 by 3. So you will have only y intercept minus 2 by